Randomized block experiments. The randomized block design is one of the many types of experimental designs used for statistical analysis. Researchers identify several factors by which to divide a sample into homogeneous groups or blocks to reduce the variance of data. To further remove extraneous variables, the researcher would rather do without. The blocks are out through a randomization process. The idea is because each block has reduced variance, which is the expectation of deviation of value from its mean. When put through a statistical process or treatment, the estimates of a parameter in each block are more efficient and accurate than if the treatment was placed upon the entire sample without stratification. Thus, the final estimates will be more accurate to the true value of the parameter. Here is the first example to help us visualize what a block design is. And here's the second one. These are nice ways of visualizing the steps it takes to set up a randomized block design. What these two images have shown is that you have a sample set of subjects, and then you define a blocking variable or characteristics you use to stratify the sample set into individual blocks. Once you do that, the blocks are put through a randomization process to remove extraneous factors, and the general idea is block what you can and randomize what you cannot. After all is done, compare observable results. This image here helps to demonstrate that there can be a multitude of treatments that the researcher wants to test about the sample. To reduce the variance of the estimates of a parameter, the treatments the blocks are exposed to are, as the name suggests, random. The advantages of using randomized block design is that it allows for flexibility in testing any number of treatments or blocks, providing more accurate results due to the stratified grouping of data, and provides relatively easy statistical analysis, even with missing data. The disadvantage of using randomized block experiments is that large numbers of treatments, though possible, create blocks that can become too large and will inevitably lead to more variance in them. So it is best to use randomized block experiments when you know that the variability of data goes in one direction. We can use the application of randomized block design in testing manufactured products or industrial engineering, which is like finding the best methods for the best price. One example is that a sample of engineering students of all class ranks are going to take a test. You want to be able to predict what the results will be and believe that the student's class rank may play a part in them. You recognize that there are freshmen, sophomores, juniors, seniors, and super seniors. So you use this as the blocking variable and divide them into subgroups. If the variance of each block is less than the variance of the entire sample, we should get strong estimates for the results of the test for each class rank. And here are the references I used for this video. And thanks for watching.